Zoom is only just from the laptop to the wall.
Okay, that's good. Sorry.
Okay, that's good. Okay.
Do you want to just close this out?
Yes, you can
I
close.
think we're good then.
Okay. Just like use the microphone for the PA and then they'll record this on their devices.
Share again. So I think we're in full control. So you got a fancy system. I don't need that ours.
Okay.
I'll be right back.
So, you gonna hear me?
Yes.
Okay, good. Finally, everybody come here and gave me their system, have some experience. So we have fun here. Now let's start talking about the introduction of ECM. First time to be here.
Yeah, I sent.
In our group.
We started already.
Good. Oh, thank you. Thank you for coming. Our local chapter actually founded in 1957, and it's 62 years old now, and older than any of the meetup around here. We promote knowledge of modern computing, create a community, supporting networks, and hiring. We only charge $20 for annual membership, so that you get all the food and the email. Big Job Person is a paper version of a newsletter. We have 2 monthly meetings, and general computing is typically on the 3rd Wednesday of the month, and data science is typically on 4th Monday of the month, except the holidays. So we create a lot of trouble for Bergen to schedule the right time for us. We recently have a joint meeting to schedule with other IEEE societies and the Valley ML.ai. We do have networks and also hiring, and as we started to offer industry jobs and posting. Now, do you want to say a few words?
Good evening, everyone. I'm Aditya Sharma. Is there anyone who's currently looking for a job? You can raise your hand. Anyone who's looking to hire talent for their company? Okay. So I asked you these 2 questions because today I'm going to introduce you a service that helps both job seeker and recruiters. So as we all know, hiring is a very expensive process. It costs companies about $2,000 to $8,000 per hire, and about 20% employees leave within 2 months of hiring date, which is like a big loss to the companies. So we at ACM have come up with a very simple and innovative solution to this problem. If you are currently hiring for your company, you can share your open job positions with us. We are going to post those job positions on ACM platform. For every job position, we are going to organize a series of webinars. And in these webinars, someone from your company, it can be a hiring manager, a senior employee, or a recruiter, it's an opportunity for you to interact with a pool of candidates, very relevant candidates. And in this webinar, you can talk about job position, or what are the requirements for it, what are your company's values, what's your company culture, typical day at that job position. With this approach, job seekers will be more informed about both the job position as well as your company before they apply, right? So it's very easy process. If you are currently hiring, please reach out to me. I'm around here until the end of the event, and I can help you set up through the entire process. And as I said, this process is equally helpful for job seekers. If you are looking for a job right now you don't need to apply online and wait forever to hear back from recruiters. You can simply come to ACM platform, look for open job positions, and sign up for webinar. And you should be an ACM member to sign up for webinar. You can simply go to join us page and sign up for our membership. Okay? So if you are currently hiring or looking for a job, please reach out to me. Thank you.
Thank you. And this venue and the pizza are provided by Walmart Labs. Let's give him a round of applause. Thanks. And you're going to do that? Okay. Upcoming events. We have the coming Saturday is September 28th, 2019, which is the one-day workshop for PyTorch and the transfer learning by the speaker today. So we offer $50 membership discount at Volvo. And this is a new place we are starting. So it's Julie, are you there? Do you want to say a few things?
Hi. We just opened in April a new innovation hub for Volvo. This is for Volvo Group, which is not the cars. It's everything else. So it's construction equipment, the trucks, the Prevo buses. We have like 12 different brands. But we're on Middlefield near Weisman. If you guys know where Symantec is, we're pretty close to that. And we're going to be hosting it there, so come see us on Saturday if you sign up. Any questions? See me after if you have questions.
Okay, the next event we're supporting is October 8th to 11th is the AI Next Developer Conference in Santa Clara Convention Center. We actually get 10% off the ticket with the specific code. Now, Wednesday, October 16th, that's our next seminar, Raise Your Facts, Making AI Works for Enterprise by the Rema Acarijo. She is a new IBM fellow. And the venue is at PayPal. Monday, October 28th, that's actually our next, PDS, no, it's next, the data science speech about the practical time series for forecast abnormality detection in Python by Dr. Ahmad Abdullah, data science at eBay. They also, he is from eBay, and he will talk in eBay. Wednesday, November 20th, that's our international patent attorney talking about efficiently protecting software innovations on a global scale by Steve Bachman at Bachman Law Group. And we're looking for venues for it. And anybody have venues for supporting this IP talk, please come talk to me. We also call for volunteers. Start with limited engagement. Volunteers can join for a monthly dinner on the first Wednesday of the month. I'm sorry I didn't correct that. That's on the downtown Mountain View. We're always looking for membership services help at the registration desk, membership back office support, and define member benefit promoting SFA ACM. As we just said, we're looking for a venue sponsor, and we also looking for PBS teacher aid for the Python, for the PyTorch course. For speaker, please repeat audience questions for the video recording. And for audience, please keep questions to 30 seconds. Any announcement from the floor? Anybody have a hiring or other event you want people to know? Okay, let's get on to the real stuff. Where's Josh?
Oh.
Thank you, Liana. Hey folks, I am super excited. So my name, by the way, is Yashish Shroff. Call me Yash. And I'm at Intel. I'm responsible for some of our strategic planning work around a number of new exciting platforms. We talked about it offline. At ACM, we have had these. Sorry. Yeah, so we've had these PDS meetings. Hello? So we've had these PDS meetings basically as a way to essentially get out of 1 hour discussions that can only take you so far. Although Ravi is going to be very illuminating in the next hour or so. But to get into the depth of the material so that you as a job seeker, you as somebody who wants to professionally develop yourself can get ahead and ask the relevant questions and get the material to support your journey. So this is, I want to talk a little bit about Ravi today, who's going to be leading the workshop as well on Saturday, so it's perfect timing. Thank you, Ravi, for doing this. You can read his bio here. He has amazing experience coming from Applied Materials, Apple, FogHorn most recently, and now I believe you're at State Title?
State's title, yeah.
State's Title as a data scientist, right? So he's played this role as a practitioner for a number of years. So I'm really looking forward to hearing from him some of the insights that he's gathered in the use of a very powerful upcoming framework, right, PyTorch. So there are a lot of nuances and differences between TensorFlow, PyTorch. A lot of people are trying to figure out that, okay, if I'm going to spend some time on this, you know, where should I go, right? Because you don't want to be stuck on the API journey. You want to try and get some work done. So hopefully Ravi will illuminate, you know, shed some light on exactly this and where PyTorch convention is at. And today I think is going to be a broadly introductory talk in terms of that. A couple of things I want to talk about here. Then are you going to come back here for the, talk in a second. I just want to quickly point out, this is the curriculum, so there's a bunch of labs. And then at the end, we're going to talk about OpenVINO, which is a way for you to take your PyTorch model, run it on OpenVINO. We have, thanks to Intel, 50 or 60 cloud instances that will not be shut off at the end of the workshop. You'll have access to these for, I think, a week or two after that. So you can actually continue playing with the models and run them on CPU, GPU, FPGA, Movidius accelerators, whatever the case may be. My Twitter is there, Ravi, reach out for more information. And we'll get back to this one. Liana, did you want to talk about this? Do we have a raffle today? Do we have a raffle today? No. All right, so without further ado, Ravi?
Sure.
Thank you. So Ravi, you'll need to do this sharing business, right?
Start video, share, okay.
Just say start share. That's it.
That's it.
Anyways, man.
Can you see it?
Covered, right?
So,
Thank you. Shake your hand.
oh, thank you. Hello, can you hear me? Okay. So should I use both? Or this is enough, okay. Can everybody hear me?
No, you're not on the mic. I cannot hear you.
Okay.
Use the microphone. The one in front of you, the handheld.
I should use this also, right? Okay, all right, no problem. Oh, great. All right, give me 1 second. All right. Can you hear me now? No. Now? Yeah. Good. All right. Good evening. My name is. Okay. I have to somehow disable this. Mute. Okay. All right. So, good evening. My name is Ravi Ilango. I'm very excited to be here. Thanks for deciding to spend a good 1+ hour on a busy business day in this forum. So what I'll do now is, hello? Now? Okay. What I'll do now is spend next 1 hour, about an hour or something, introducing you to deep learning, PyTorch with some demos. That's what I'm going to do. Before I start off, how many of you are familiar with deep learning, have been practicing data science, those kind of things? All right, okay. All right, I may go into some basics also to start with, and since we have enough time, let's make it interactive. Feel free to ask me questions and we'll go with that flow, okay? All right. The worst thing I can do is I would say that I don't know. That's the worst thing I can do. So feel free to ask questions along the way. This is my bio. I think we went through this. My current job is principal data scientist at States Title and SF, and we are also hiring. If anybody is interested, let us know. Mostly in the NLP area. Okay, all right. So let's start with some basics here. So what's deep learning? Deep learning is a subset of machine learning. You start off with the artificial intelligence, which is basically making machine behave like humans, right? Machine learning is machine learns from previous activities and tries to do this by itself. And deep learning is just one algorithm which does it pretty well in certain areas. It does very well in image processing, audio processing, and natural language processing, right? In all these areas, deep learning has proved that it can do pretty well. Some of the artificial intelligence applications, you see this in a day-to-day life. You see Netflix, Pandora, what is this? It's Alexa, all these kind of devices, mostly around speech recognition and image recognition. It does wonderful things on a day-to-day basis. Today it's happening, right? 3-4 years ago, people are just saying that it might happen, those kind of things, not 4 years ago, at least 4-6 years ago. Now it's actually the whole thing is happening, which is pretty good. So let's talk about what machine learning is. So most of you are practicing data scientists, which is pretty good. It's all about finding patterns in data, and it uses statistical learning. Okay, so you feed the system a bunch of data points. It learns from it, and it starts using it again when a new data point is given. That's pretty much what machine learning is all about. This is again basics. Just stay with me here. I just want to make sure everybody is on board. Basically, in terms of a supervised learning, what you do is you take labeled data, and a machine learning algorithm learns from it, and using a learned model, it actually does a prediction. Let's take an example. A labeled data could be images on the stores, in the retail stores, showing different kind of products. And for every product, there is an image and there is an answer. Feed that information into a machine learning algorithm, it will figure out the relationship between the data and what the answer is going to be. It will learn it and keep the algorithm within itself. Right? Then when you provide a new product, it's going to tell you what it is. It's going to tell you it's a banana or whatever, right? And you start using it in business for whatever reason you want to do. That's the basics of machine learning. And deep learning is just one algorithm which does very well in certain areas. This is a mathematical way of simplistic way of saying it. In machine learning training, there is an input X. There is a model which does the prediction. The prediction is based on a function. Function means it's got a lot of parameters and a funky equation, and that particular parameters needs to be searched based on your training data, right? The way it does is you do something called a loss calculation, and you try to find the best parameters for the model. Is everybody here familiar with the basics of machine learning? Loss, optimization, okay, I'll just skip all those kind of things. All right, we went through this is good. So again, applications, speech recognition, computer vision, and natural language processing. Computer vision, this is clearly deep learning has proved itself. There is a lot of applications in productions today. I'm not talking about what Google or Facebook, these kind of companies are doing. They are actually having the product as part of their product, right? I'm talking about in business corporations where they're using these computer vision to do business activities. That is started happening now, right? For that to happen, people naturally have to use a lot of frameworks for doing this particular training. And currently the kind of frameworks people use, they use TensorFlow, Keras, Caffe, quite a bunch of things, MXNet and PyTorch. And today I want to focus on PyTorch. The reason I want to focus on that is I've used TensorFlow, I've used Keras. In my recent company in FogHorn, when I was working there, I had to solve a manufacturing problem. right? I'll walk you through some of the examples. I cannot share the code or something, whatever we did there, but along those lines, I have some example I can share it with you, which is why I'm just excited about using PyTorch, right? So it made it so easy to use in a commercial manufacturing defect detection application. I thought Keras was it. Keras was like, how many people use Keras here? Okay, do you like it? Good. So it's because it's like English. You don't have to worry about a lot of different things, right? So I like Keras. I used to teach this class before. I always ask people, hey, you should use Keras and other things, but it had some limitations. But if you want to do some custom stuff, it's always difficult to do. But if you start using PyTorch, it's one level easier than that. It's much, much easier. And one gentleman was asking me, why do you think PyTorch is better than TensorFlow or something like that? Is since I started using PyTorch, I rarely go to Stack Overflow. That kind of speaks for itself. So you don't spend time in APIs and fixing all the unnecessary problems, especially if you are an applied data scientist, right? If you are an applied data scientist, you are worrying about solving your business problems, right? That's the where you are going to focus on, as opposed to worrying about APIs and other technical issues. PyTorch is so easy to do. So I'm so excited about it. So I'm not taking money from Facebook or PyTorch. That's not the reason I'm saying it. I really found it very, very useful in my previous company. Even my current company, I'm planning on using it. Again, for natural language processing, again, PyTorch is again useful. Deep learning itself is very useful in natural language processing, and I see in terms of job opportunities, if people are learning deep learning, the computer vision is kind of saturated. Everybody using a school kid can come and create an image classification model, right? They can do it in no time. But natural language processing is now getting there. And pretty much every corporations, when they want to automate stuff, they need solutions with using natural language processing. So if you want to spend time in learning new stuff, think about NLP. Again, deep learning basics. Do you guys want me to go through this? Yes. Okay. So it's all about what I told you about. A machine learning model is about postulating that this particular problem can be solved with a function, right? And setting up the function, then figuring out what exactly the parameters are. And in terms of deep learning basics, it kind of was inspired by neurons. Neurons are in our brains. The way neurons work is it gets impulses as input, and if you see all the 10 neurons on this side, these are all the inputs coming through, and it provides an output, right? And it gives kind of different priorities based on what inputs it's getting and figures out an output, kind of, right? It's continuous function. That's what it does. And equivalent to that, if you want to talk about an artificial neuron, you can see how many inputs are there, x1 and x2. There are 2 inputs there, right? And there is the one more, sorry, 3 inputs, x0, x1, and x2, and plus there is a bias. Let's forget about that for a second. There are 3 inputs coming in. All the 3 inputs are multiplied by some kind of weights, W0, W1, and W2, which means it's given relative different importance based on whatever it is, and it's going to come up with an output, right? Now, let's assume that these 3 inputs define an image or something, right? The 3 inputs, it would x1, x2, x3, or it could be every pixel in an image, which could be thousands of values. If you have things coming in and magically you figure out the right weights to apply and come up with an answer, then you are done. You have a function which is going to provide you the output we need, right? And the key is, how do you figure out the W0 and W1 and W2, which is going to solve your problem? That's where the parameter search comes into picture, and you use backward propagation, deep learning, and sorry.
Be careful your foot.
Sorry about that. Okay, is anybody logged in or something? Everybody is here physically? Nobody is remote, right? Okay, all right. In my last meetup, some people were logged in from Seattle or something. Okay, so that's basically the weights get determined, which is we call it as a parameter search in statistics. Okay, go ahead.
37 viewers. 37
Online. Oh, okay, great. Okay, all right, great. So the parameter search or backward propagation makes sure that all the parameters W1, W0, W1, W2 are figured out so that it gives you, the function gives you the answer you need. And it is not a single neuron which is going to solve the problem. You want to make life difficult. The neural network model will look up something like this. So these are all the inputs. Whatever you see on the left hand side, these are all the inputs. This could be again pixels or some other business parameters, anything, any variables. And all these are sent to the next layer, and every one of these, the second layer, whatever circle you see, that's a node, that is a neuron. It does the same computation what I talked about. And again, the output of that is sent to the next layer, again the same computation. If you really want to formulate the final output in terms of input, it would be really a funky equation. Can you imagine that? Too many parameters with all kinds of stuff. In addition, the output activation could also be a nonlinear function, so to make things worse. So that's such a complex equation you have got, and the backward propagation nicely works to make sure that it finds the right parameters so that you can get your output. Are we okay here? Okay. And the foundation of any deep learning platform is basically the backward propagation, figuring out the partial derivative, those kind of things, so that it can do the parameter search for you. So TensorFlow has the built-in capability. Similarly, PyTorch. All these are fundamentally, that's the cream, that's their secret sauce, right? Not secret sauce, but that's the cream foundation. How do they do the backward propagation? Come up with the right parameters. Everything else doesn't matter. Once you have that the function figured out, the parameters figured out, then it becomes like any other model, any other random forest or logistic regression or any other model. Any questions here so far? Good. It's all basics. Sorry about going through this again. The equations looks really funky if you really come up with the final y2 in terms of x1 and x2, it will be really a funky equation. That's what this is supposed to illustrate. I'm not going to go through all those kind of things now. Okay. All right. Let's talk about a simple task in computer vision. Again, I'm going through some basics again. Please bear with me, just to make sure that you guys get the image classification clearly in your head. So this is on the left hand side, you have the input image. On next, what you see is the pixel representation of the image. Basically, the computer sees this as a pixel representation. It just sees numbers 0 through 255. Assume this is a gray pixel, so you have only one layer. You see some numbers. That's the only thing it sees. It doesn't see anything else. And magically, there is a classification arrow. That's where the ML comes in. Your deep learning model comes in. It somehow converts these numbers into a set of probabilities of possible 4 classes, and I'll be using these kind of terms. The possible target classes are Lincoln, Washington, Jefferson, and Obama. It comes up with a probability for every one of them. How it does it is using that function which I talked about. And you figure out using lot of training, giving it lot of images, it figures out the right parameters, and finally you have a function which provides you the right probability here. Here it says 0.8 for Lincoln, and you say, this should be Lincoln, and it is Lincoln, right? So that's how the computer vision problems are solved. Again, not to bore you too much, this is how it works. Your pixel representation is fed into the first row. The first row has only 6 nodes. Actually, it is supposed to have the number of nodes should equal the number of pixel values coming in, including a bias, right? Then it has got multiple hidden layers, but it goes through complex calculations, and finally output layer spits out the probability, right? That's what it's doing. And coming to think of it, this is basically a computational graph. The neural network model is nothing but a computational graph, and that's what you define when you define a model. Okay, so far whenever we say that you're defining a model, we are going to define a computational graph with unknown parameters. Then you train and figure out the right parameters. All right, now in jumping, I'm going to use some words CNN, assume you guys know, but I'm not going to go into the details. If you come to the Saturday class, we will go through this in step by step. CNNs for classification, it is something called convolutions. Instead of straight away using the pixels in a braided way, you actually look at the pixels 3 by 3 or 4 by 4, those kind of things, because the where the pixels are makes a difference to a 2D image, so it provides better information, and it goes through multiple layers. On the left hand side, you only see an input. It's a car. It's a 2-dimensional image, and it goes through these whatever you see, all these cubes kind of a thing, 3-dimensional, they are all basically layers, different layers. It goes through different layers. All the computations are formed like the way I explained before, and ultimately it's going to give you a classification of, I don't know whether you can see properly or not, the classification are car, truck, van, there are some 1,000 classes. That is what it is going to give, okay, all the computation. The initial layers are called feature learning. The way it does internally to intuitively to understand how the image processing works is, it takes a look at the image here, and it first initial layers, they look at slashes or curves, dots. It basically looks at the basic strokes used in drawing the pictures. That's what is coming out here. And as you go along, it puts the pictures together, all the shapes together, and finally figures out what kind of a shape or what kind of a, image it is, and from there it does the classification. That's how the whole learning is done, right? And if you, I'll come to this later. Let's look at this picturization. This is how it normally works. Depending on the problem here, we are providing a bunch of 3-dimensional color image of a person, and we are trying to detect something with the face. That's what we are trying to do. I don't know what exactly the problem is, but that's what we are trying to do. All the layers we see are the different deep learning layers where computation is done based on the pixel values. If you see the initial layers, you see all the dashes and the basic strokes are getting detected. The next one is nose, eye, it's putting together small pieces. And finally the face is, it's actually figuring out the different features which will formulate the face, and finally with that information you start providing, start detecting whatever you are supposed to detect. Does it make sense? That's how the whole learning piece is done. The reason I'm going through this is I'm coming to transfer learning here, right? So this is how the whole network is going to look like. You start off with a car, you have a bunch of feature learning, which is basically all the curves and everything. Then you put things together, which is called a classification, couple of 3 layers, which is a classification layer. You flatten the CNN, then you make it as a fully connected. When you say fully connected, all the nodes are connected to each and every node. Then you have a softmax, which introduces a non-linearity, and it produces a probability for every one of those classes. That's the last piece. And that's how the typical CNN training is done. On the bottom you see, that's called the loss. Loss is the one which basically guides the framework through backward propagation, and as well as making sure you get the right parameters. Let's stay with that at this point. Now, let's talk about transfer learning for a second, right? I'll go back and forth on this. Transfer learning. So, the one problem I had in my previous company was we didn't have a lot of data, right? It was a manufacturing defect detection problem, right? We didn't have a lot of data. But we had to do a defect detection. We had to create a defect detection model. So, when people are doing training with ImageNet, let's go through some of the ImageNet problems here. So, ImageNet dataset is being sponsored by Google, Stanford and Princeton University and all those kind of people, and they have 14 million images across 21 plus K categories. So, they got so many images in ImageNet. So, they created models which would classify an image to one of these objects, whether it's a banana or whatever, mango, those kind of things, and they could do it because they have 14 million images. And people like you and me, we don't have access to 14 million images. If you go to any manufacturing company, first of all, we ask them training data, they'll ask, what are you talking about, right? They don't even have time to do their work in terms of manufacturing goods. Forget about capturing images and actually labeling and other things, too much work for those kind of people. Even if they are going to give you only 1,000 or 2,000 images. That's a lot of work, right? Especially if you're in the business of soliciting and basically you're pushing your solution, you don't get a lot of support for creating training data. Does anybody have that problem in their business? Creating of training data, it's always a challenge, right? You never get the data. So in that situation, you don't have 14 million images. So what do, right? That's where the transfer learning helps. So this is from CS231 course in Stanford. You can go and take a look at it. I'll just read through this. Very few people train an entire CNN network from scratch, right? Because they don't have data, right? So it's very common to pre-train a model using ImageNet, right? When you pre-train a model using ImageNet, what do you get? You get, I'll go back and forth on this, when you pre-train a model using ImageNet, you get weights or parameters for every one of those layers trained for 14 million, with 14 million images. And remember, when the parameters are trained, what does it train for the first few layers? It's not going to get the car. It's going to look for the curves, straight lines, and those kind of things, which is common for every application, right? If a system knows how to get this information, why should I not use that piece alone? That's the idea of transfer learning. So the transfer learning, what you do is, you take this model, the complete model, the first few layers, which is feature learning model, one way to do the transfer learning. There are multiple ways to do the transfer learning. I'm just talking about one. What you do is, you take the feature learning, you want to leverage of the work done by all these guys using ImageNet, you freeze the parameters whatever they gave you, which means you now have a model which can detect all the curves and small little pieces out of your image.
Till what stage do you freeze?
Typically all the feature learnings, all the convolution networks.
So you mean all the way till your feature learning?
Yeah. So the question is, till which layer do you freeze for transfer learning, right? So if you take a look at a pre-trained model, it has got basically the feature learning, all the CNN network, the CNN layers, and at the end it will have a fully connected layer and probably a classification layer. So typically what you do is, wherever it is doing a generic feature learning, you freeze up to that point, right? Then later on, the rest of the images, you start the rest of the layers, you train using your data. Since it's a fewer parameters needs to be trained, you don't need a lot of data, and it works well. Trust me, I was shocked to see the results when I ran this, because we were working on that particular problem for 1 month or 2 months, trying to break our head to get some kind of accuracy using image segmentation, all those kind of wonderful things. Using TensorFlow, I dropped Keras because I didn't want to use it for whatever reason. I went for TensorFlow, and after 2 months, I want to try out PyTorch for something else. Accidentally, I went for it. Within a week, we had a solution.
What was the problem?
Which one?
The problem you're describing.
That was a manufacturing defect detection problem. It's a binary classification. Defect, yes or no. That's the only thing. Okay. In a color image. It's not other. Okay, go ahead.
So you notice that most of these models are trained in ImageNet, which is a 3-channel, right, RGB. What if you have a grayscale image? How will you fix that problem? Because the network will still be expecting a 3-channel, like an RGB image.
Good question. I tried that. So the question is, typically all the pre-trained model are trained using color images, which is RGB images, which means your dimensions are 224 by 224 by 3. That's how it is. And the whole model is set up to behave that way. Suppose your real life problem is a grayscale. So what do you do? One thing I did was, I don't think I have the answer for it. I did a similar problem. I had to do it. What I did was, I copied the grayscale into all the three layers. It should work.
Is that like optimal or is that suboptimal? What do you think?
It worked for me. It worked for me. I used it not for transfer learning. I used it as part of the loss function. In the loss function, we were actually comparing not the classifier predicted output. We were comparing the output of VGC 16, 4th layer, 17th layer. That's what we were comparing. So it's a different kind of a problem. At that time, I was forced to use, I had to go to the same problem. I just copied it. It worked for me. So that's one. Any other questions? No. All right, very good. So that's the key. So you leverage of, I'll tell you a few more ways to do the pre-training also. As we use the pre-trained model. This is one normally used way, which I have used it. There are other ways also. Let's go through and see what the professor says here. You can use it in 2 ways, that's what he says. There are more ways. I'll come to one more thing also. One is as an initialization. So it's not freezing. You just initialize using a pre-trained model and use a very low learning rate to train your 1,000 images or 2,000 images. It might work. It's an experiment. At the end of the day, deep learning training is an art. It's not really a science. You have to try different things to see which one works for you. That's very important. So you can try this, but for me, this never worked for me, but this is something which you want to try. And the fixed feature extractor is what I told you before, which is basically fix the convolution network and then do it. Let's go back to this, the question you had asked. So I would initially start with freezing all the feature learning and doing the classification, right? If I have enough data, what I will do is I'll start releasing the last of the feature learning layer. Are you following me? So when I say I freeze these feature learning, which means all the parameters there are fixed, and I can only change the parameters for the classification layer, right? That's one default. I'll see how my accuracy is. Then if I'm a little bit adventurous, what I'll do is the last layer of feature learning, I'll just unfreeze it and see whether that helps. So I can just keep doing it. What you cannot do is you cannot select one middle layer somewhere here and say that I'm going to unfreeze this. You have to do it only from the end, because the backward propagation works like that with the chain rule, right? You can't skip certain things. I don't even know how it will behave if we do that. Are you okay so far? Okay, good. All right, so that's a wonderful thing of transfer learning. Again, let's take a look at the ImageLint challenge. They got AlexNet, ZFNet, then VGG won the competition, GoogleNet, ResNet. I have successfully used a couple of ResNet layers in production during the last 1 year. I'm pretty fond of it. So classification, if you want to go for certain problems I had to face, where I had to do an image reconstruction, where the people gave a blurry image, we scanned the images, and we had to reconstruct it. I tried every model except for ResNet, nothing else worked. It was very, very powerful. So I would say that give that a thought too. You can try everything, but ResNet is pretty good. Go ahead.
So I was looking at your images, for example, like the banana images you were
Yeah.
right? So something, for example, let's say some country which is completely isolated, suddenly zero banana comes into the picture. I'm just throwing some example. And let's say that's a very big in size, which is not in our data. So those kind of scenarios when we actually deal with the problem, like new data comes, so how do we update and how, because so it should be perfect, so it should be the right.
Yeah, if a new data comes in, the question is, you already trained the image with lots of objects. Unfortunately, bananas was not there, let's assume. Suddenly bananas comes into picture, and suddenly this one comes into picture, what happens? It's a straightforward thing. First of all, it will try to attempt to classify it to the extent it can. You can probably call it a cucumber or something, that's what it will probably do. But it's actually your job as a person. I think that's another thing industry is learning. Everybody is good at creating a model, but people haven't figured out how do you maintain a model in production. They have not figured it out. Everybody is throwing models out, hey, this is good, 98% accuracy and other things, but how do you measure that it's maintaining that accuracy, and when you have to retrain? People have periodic retraining, that's one way to do that. And there is another thing which we introduced in our previous company called closed loop learning, where we look for data drifts, right? In this case, it will be data drift. We will figure out that, hey, we haven't seen this kind of data before. It will say that, hey, your data has drifted, which means your model is no longer valid because it has not looked at this data. You have to go for a respin. So that's the way you start doing it. Either a periodic respin of the model or look for statistical data drifts. That's what you should do. That's very, very important. Very good question, because this is something nobody is focusing on. People now slowly learning how do you actually manage things in production. I'm pretty sure from now onwards you will see standard tools coming in for doing it. I don't think today there is a tool saying that, hey, this is how you should manage things in production. If people have ideas, go out and develop it. It'll come to you.
Based on this graph, it looks like ResNet has now surpassed humans on classification.
Yes.
Do you think the industry will just say, okay, that's good enough, or do they want to keep making it smaller and smaller for classification?
I think you can always make things better and better, right? So, yeah, I think what this tells you is whenever you see something doing better than humans, this is a candidate for automation. If we can do speech recognition better than humans, yes, AI can do it, machines can do it, right? If it is just doing above humans, it's a hard sell to the business. Hey, I'm going to give you the application, but you have to deal with this extra failures. Nobody is going to buy it. Nobody cares about all your algorithms and other things, but they will tell you that, oh, this is giving me a worse performance, why should I do it? But if it is behaving better than humans, it's an easy sell. I'll come to you. Okay, thank you.
Is it correct that's a 1,000 classification, and you're talking about top 1 accuracy?
Say it again, sorry.
ImageNet.
Yeah.
Number of classes, it's 1,000.
1,000, yeah.
Right, and you're just talking about top 1 accuracy? The first class, not the top 1, just the top 1 accuracy.
Yeah, this one is the top 1 accuracy, yeah. This one is the top 1 accuracy, yeah.
I thought I saw 21,000 classes in
The data set has 21 categories. I think when you start using it for a classification, only 1,000 classes are available. Okay. Next question. By the way, I'm not an expert in ImageNet. I have not trained in this kind of thing. I'm a user of ImageNet pre-trained models. Go ahead.
So in ML, whenever we have an engineer whose solution is not working, they always blame the data. They say, oh, you didn't give us enough data. So when do you know that you have enough data points? Or is it a problem with the model itself? Is it inferior model, or we need more data to spend time and money to get more data?
So as part of the model development, what you do is you have to come up with an expected accuracy, expected prediction accuracy. And when you develop a model, you set aside a data set. Say 40% of the data set is a holdout data set. You say keep it separate. Use the 60% of the data set for training, and use the 40% of the data which has not been seen by the model to do the prediction. And you say that, oh, this is 98% accurate, or 84% accurate, or 85% accurate. That's how you set the expectation that if I use this model for future, this is my future data, my expected accuracy is 84%. That's important. People don't do a good job in setting up the expected accuracy properly, then they'll run into this problem. That's number one. Number two is the problem with this gentleman said, right? The data drifts after going to production, right? Then what happens? So you should have a process for taking care of any data drifts so that you can start respinning the models. Let me come back to you on the other end. So depending on the model, there is no easy way to check things in production. There is no easy way. It's all anecdotal. There is no easy way, right? If there is clear way saying that a train is going to crash, it doesn't crash. Those kind of things are easy way to measure. But if you want to see that how many times it did the detection properly or not, it's very, very difficult to measure in production. Very, very difficult to production. So I don't know that I'm answering your question or not. As a data scientist, even in developing the model, I need to set the expectation clearly, saying that based on the data what I have seen, this is my expected accuracy. As long as the new data which comes in is similar to my data distribution, it falls in the data distribution, I am expected to see this accuracy. That should mathematically and statistically that should work. If your data distribution changes, the data scientist doesn't know about it. So you should have a process to deal with that. That's important. And if the data scientist didn't do a good job in calculating the model accuracy, then it's a different issue altogether. Okay. Is there any specific example you want to share with people, or it is just
So we have a solution where what we did is internally we had enough data and we saw some good results.
Okay.
Once we took it to production, sometimes it does a very good job and sometimes it just wasted time and you have to go back. In the production environment, people lose confidence
That's
They're
true.
happy to use it again.
That's true. That's true. Yeah, you have to set the expectation right. For any model, what I would say is set the expectation that, hey, let's set a low bar on the expectation. Just go with the lower expectation. This is how it's going to behave, and you have a good way to measure whenever there is some outliers happening, right? And you should work with people for a month or two, or depending whatever the time period is for getting the new data which is not getting labeled properly. Get that part of the training data set. The accuracy can only go up; it cannot go down. In generally speaking, right? So that's the change management process you need to work on. Again, depending on the criticality of the application, you need to decide how much upfront work you need to do. If it is a business critical things, like you're dead if something is wrong, that's a completely different story. There are other things where you have a backup process to work with. If there is a problem, then you have some time to make your models better. So it's a subjective question, but it's important. Very good. Anything else? All right, we talked about transfer learning. Oh, go ahead.
So like company like PayPal, they used to use models to find fraudsters, right? So if a company of those kind of scale, I mean, they depend on these models to take their decisions. If there are 94% correct, 100%, how they can run their business?
Okay, the question is, companies like PayPal use these kind of models for figuring out fraudsters, right? And if the accuracy of the model is 94%, how do they deal with this in the business, right? So again, when your accuracy in terms of just like, you don't look at only the accuracy, you use some other measures like precision and recall, not to confuse people. It all depends on your particular business applications. Can you live with some false positives, right? Because or other way around. So in this case, for a PayPal, it's more important that they can even be 80% accurate, but they want to make sure that all the frauds are caught, which means they'll have a lot of false positives, which they can work around using manual or second level of review, right? In some situation, they are okay with catching 98%, 2% of the fraud, because it's too expensive to take care of all the frauds. 2% of the fraud, if it goes through, it's probably from business perspective, it's okay with them. So that's a business call. But again, it goes back to what the gentleman said, is we have to make sure that the model accuracy has to be tuned with the business purpose, the end business goal in mind, so you can tweak for less false positives or more false positives. All those things you can do. As part of your model tweaking, you can do that. And you have to set the expectation right. That's important. Good question. Anything else? Okay. All right. This is again, this story, I don't know whether you get to go through this. This is basically the same information shown in different way. There's a lot of different models out there. Again, my favorites are all these resonant models. I used resonant 18 because the previous company where I worked on, we want to get a good speed. That's when speed was very important for us, because we had to process 40 images per second. So fast we had to do. So our scoring should be done in less than 10 milliseconds. We came down to 8 milliseconds. We used PyTorch and we used OpenVINO, Intel's OpenVINO, to get the right scoring model. We used RS18, which means the scoring, the inference millisecond is pretty low, which is good. Even though it had, from accuracy perspective, it's not great, but speed perspective, it was good. All right. So if you go to this particular site, I have the site pytorch.org, you can just Google it, stable torch vision models. They got pre-trained model for all these wonderful things. Image classification, which is what we talked about, right? Semantic segmentation. Semantic segmentation you can use for medical images, for figuring out where your some bad tissues are, those kind of things, right? Semantic segmentation. Object detection. There are pre-trained models, which is CATs, whatever, that you can find out where some objects are and what is the area, bounding box for that object. You have that. I don't have a picture for this. It's a person key point detection. Where is your nose, hand, those kind of things. This is a pre-trained model. Video classification. I liked it actually. If you come to the Saturday course, I think we will go through most of the examples as separate exercises if you choose to come to the Saturday course. But you can do it yourself too. Go and take a look at the models. They are all pre-trained. We will go through one of the demo where we will use some simple classification models. How easy is it to code? And you can take it from there. NLP, natural language processing, it's pretty hot off the press. They have PyTorch, PyTransformation. They have released some cool code in July for NLP processing. So I'm going to try to use it in my company, but I haven't done much work on this at this point. So pre-trained models are good. I have personally used image classification. The other things I have not used the pre-trained models yet in production so far. Okay. Any questions? All right, we'll just go through how are we doing at the time? 8 o'clock. Okay, I'll start the demos. What is PyTorch? It's Python-based scientific programming language targeted at two set of audience. It's a replacement for NumPy array to use power of GPUs for doing all these wonderful calculations. And it is a deep learning research platform that provides maximum flexibility and speed. It's a research platform, and that's why they don't have a good scoring system. They have Torch script and other things. I don't believe it, but they're about any paper you see in kernel library and other things. If you want to see the implementation, you will see a PyTorch implementation. Then only you will see other implementations. So the research community love PyTorch, and pretty much you will get a lot of help from that perspective. Okay, go ahead.
If you are mostly developing on a MacBook, which is CPU based,
Uh-huh.
you intend to use it on GPU.
Uh-huh.
Can you still work with PyTorch?
Yeah. You can use the CPU. The question is, if I'm using a Mac and I'm doing a training using CPU, later on I want to use the same code in GPU. Can you do that? Yes. We can set up the tensors in CPU kind of a tensors or GPU kind of tensors, and we can train the model in GPU mode as well as CPU mode. It provides both things. It's pretty strict about it. You can have to choose one of them. Okay, so that's not a problem. It will be slow, but it's not a problem. So kind of a PyTorch workflow. It's a pretty straightforward. You have the training data, and whatever you see on the parentheses is the modules it uses. You create a network, which means that's the model. .nn is the one you use the models for. Train network is using Torch, Optim, and as well as AutoGrad. One is for optimizer, another one is for automatically creating gradients and wonderful things. Using those 3 steps, you create a trained model and use the trained model and the testing data for getting the predictions, which will set the accuracy in everything for future use. That's how you predict the accuracy of the model. And for model interoperability, it is torch.onyx, which means you can get the model, convert that into Onyx model. Onyx is an open source format. Once you have that, you can use OpenVINO to create a faster inference engine, or you can even move it to some other frameworks for faster inference. Okay, that's pretty much what it is. Published models, Torch Hub, I have not used it. Pardon?
Which format are you referring to?
Yeah.
If I convert it into Onyx, would it be easy for me to load that in TensorFlow and use it, or would that?
Yeah. For the interoperability, you can actually from the trained model, you can convert to TensorFlow directly. You can go to TensorFlow directly, and from TensorFlow you can go to other things. But Onyx is the open source interoperable model. The way I used it in my previous company is I train it this way. Then from Onyx I convert that into Intel OpenVINO, and Intel OpenVINO creates a model which can work really fast on an Intel machine. So we could get a model working, doing inference at 8 milliseconds.
And so that's what you would use for production, right?
Yeah, it's a CPU machine. I'm not talking about big GPU machine. I'm talking about a small machine in a manufacturing assembly where you don't have a lot of space. And we bought an Intel box. It's a pretty powerful machine, but it's a CPU box.
One more question, sorry. So for example, let's say you trained your model using GPUs, right? And you created your model using GPU. Can I actually use that, the Onyx model?
Yeah.
Can I use it in CPU?
Yeah. No, nothing. So remember, So, just, zoom back. The question is, I am training the model in GPU, can I use CPU for scoring purpose? Zoom back for a second. What are you doing for the training? By training, what we are doing is we are trying to find out the function of x with some parameters. And the reason we are doing GPU is the backward propagation, the calculation is much faster. After that, it does not matter. You have a bunch of weights and a mathematical equation. You can basically take it and run it wherever you want. The GPU is not in the picture anymore. Fair enough? The output of this is a function of x, which is basically a bunch of it's a graph, mathematical graph along with weights.
So the reason I asked you that is because I noticed that PyTorch has the CUDA tensors and CPU tensors.
Yes, you have to.
It has like that issue of if you don't.
You can't mix and match. You can't mix and match. So when you set up the model, you should say that this is for CPU, and the tensor should say it's for CPU, and it will work. It will work. You should not confuse it. That's why. Good question. All right. Okay, so we're going to do a demo. It's already 8:15, I think 8:05. We'll do a demo. And where is Sachin? Sachin is there? Oh, okay. All right. Good. You're there. So this is. I'll start with this. I had some easy things. I think probably there is a gentleman over there who is working on some medical image detection problems, and this will be useful. So this is the problem here is we are trying to detect a malaria, and what you see on the left hand side is affected, on the right hand side is not affected, right? I am not a doctor by any means, but by looking at this, there are some spots here, there are spots here, there is no spots, probably that is why it is not affected. Okay, so it's that is why it is doing it. Fine, with my naked eye I can do it. A rule of thumb, what I use in terms of image classification is what I tell people, my customers too, if a human can identify by looking at the image, the machine can do it. If a human cannot identify it, still the machine could do it. It's possible. I have seen it, right? Because you are not smart enough to see certain patterns. Okay, all right. So I will go through this demo. So I am going to log into. This is an AWS machine. Hope everything works. It's already here. Demo, classification. So I got two Python notebooks. The first Python notebook will use the fixed convolution network method, which means it's going to freeze the convolution layers, and it's going to do the training only for the last few layers. I'll walk you through the code because it's pretty intuitive and self-explanatory. Let me go through this nicely. Can everybody see this? Is this is better now? Can you read the code? You don't have to memorize the code. I'm just getting a feel of what's going on. The first step, like any Python program, we go religiously import modules, right? Whatever modules are required, we just import it. That's done. Okay, and the problem again here is two sets of data, affected and not defected, and we are going to detect whether it's good or bad. That's what we are going to detect. And then typically what I haven't come to the training part yet, we are going to examine the data. That's what it is. So we can actually go in here and say, okay, let me run this. I won't do the training alone. That's the only thing I won't do. Everything else I can execute. The training takes around 1 + R, right? So image directory. So there are two directories here, parasitized and unaffected. This is bad cells and this is good one, right? So I can see what's inside that, and just look at these images for a second. And these are the PNG images. That's what it is, right? These are the input images. And just because it is under this directory, it's already labeled. You see what's going on? It's labeled. This means 0 label means it's having malaria, and 1 label means it doesn't have malaria. and like I am just opening some files here. So, here it is, see here, this is a bad one. You can try one more if you want. This is also a bad one. So, all this is how the data is. Okay, so far, okay, you have the data, it's all done. Then we can easily, using PyTorch, you can do some transformations, right. Do not worry too much. Typically, when I used my last project, I just used my default. I did not even do a lot of this transformation. I just threw out certain things. But the bottom line here is you are doing some random rotation here, which in this case it is okay for a human tissue or cell analysis, is okay, even if it gets rotated a little bit, it does not matter. In my problem, what I had done before, the random rotation was not allowed. It has to be in the certain angle. So, I did not do all those kind of things. All I did was transform the center. I made sure that size equal to 224, because I made sure that in all the different sized images, it cropped only the 224 by 224 image, right. It does all those kind of things. You set up your transfers, your transforms, it is pretty easy to do, and you do create, training, test and validation for everything you set it up. Then you load the data. Here purposefully what I did was I loaded only less number of training data, because I am going to do a transfer learning. I just took 30% of the data and made that as training data set. Validation is 20%, test data set is 10%, which means less of the 40% of the data I am not using it, just for the heck of it. I did not want to use all the data. So, I can load the data and you can see this. For training, now I have 8,000 images, fair enough, which includes both the classes, around 4,000, 4,000, that is the distribution. Here is the beauty part. The model definition, typically, I will go here, I will take a look at another sample here. It is a cipher classifier, right. This is how you normally write a PyTorch program. Like Keras, you define a model, usual thing, right. I will just go through this, the same thing. See here, you have to define a convolution network. You are setting up a convolution model, pooling, blah 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 and other things. Then in this initial one, then you add to the forward pass, you start adding all these layers, then that becomes a whole network. It is like Keras, it is pretty straightforward to do, right. Now you come to a transfer model. All you do is, I am going to call model equal to models dot resonate 18, pre-trained equal to true. Boom, the model gets loaded. You do not have to know anything about the model at this point. Okay. If you want to know what other models are available, because it's see, all these models are available, whatever I showed you before, right. All the pre-trained models are available. Instead of resonate 18 is not giving good performance, you are okay with a slower inference engine, go for resonate 50 or 34 or 152 or 101. 101 means it has got 101 layers, which means much more complicated model. We can just build it, no issues. So, I am going to load this model, I think it is done. Now, this is a statement some gentleman asking about CUDA and the CPU, right. If it is device is CUDA, then it just comes up with what device it is. Right now, I am using a GPU device. So, I should be able to see this as GPU, type equal to CUDA. Okay, it is all done. The model, if you print out, this is how the model looks like, which pretty much is, these are all layer 4, these are all basically the feature extraction layers, which we talked about before. Let us come back to the final layer. This is what we need to change. The final layer FC is linear, it takes 5011, out features is 1000. Why do you think the output features is 1000? What is that?
1,000 categories.
Yes, the ImageNet has 1000 classes, 1000 categories, because remember this was trained for ImageNet and they had to classify 1000 classes. That is why they kept it, but we do not care. We want only 2 classes, right? Good or bad, that is all we need to do. So, what we do here is, this is what we do. We got the model in, this is just output. We do not have to write all these kind of things, we just know what it is. Then what we say here is model dot parameters, we say require underscore grad equal to false, which means there is no gradient calculation required. There is no backward propagation, which means all these parameters are fixed. Nothing gets changed during backward propagation. So we just fix everything, which means we have fixed everything. Then what we do is the final layer, we add this. We add a ReLU dropout and we add a softmax. Basically, we get a 2-layer output. That's a 2-point output with the probabilities. Not probabilities, we 2 points output. Then you can figure out which one is minimum or maximum and figure out what class it is. That's what we need to do. Okay.
Where is this models library coming from? Is that externally provided or it's part of PyTorch?
Models? Yeah, it's just I took directory of models, right? Let's go back and check what it is. Here it is. It's part of Torch Vision. Fair enough? The question is, where is this models coming from? It's part of Torch, which is PyTorch Vision. They have provided this, right? Which is good. All right.
Question?
Yeah.
When you turn off the gradient updates, I thought in transfer learning, you're still supposed to update the last layers.
Yes.
Add in transfer learning.
Good question. The question is, you turned off the parameters, gradient for all the parameters, then where is the transfer learning happening, right? If we see this, at this point, model has some FC and we turned off all the parameters. Then we changed the lot FC layer to this one. As a default, whenever you start defining a layer, the gradients are turned on. Okay, and you can even check it, right? Did I do this? So we can actually check it. Let me verify that. And I should be able to see this, right? Requires grant. How do I do this? Doing a list comprehension here. Will this work? This should work, right? Nope. What do I do?
Requires that you have been missing an S. Required underscore that. Parent dot required with an S.
No.
Yeah, pretty much sure. So you just have to add an S there because and the plus.
What is that again? Sorry.
Basically, parent dot required with an S.
The required in the grant should be requires underscore grant.
Yeah, that's it.
Oh, you're right. Thank you. All right. So it says S for everything. Should have false, right? Let me see.
You have to set there requires radicals.
Yeah. Let's not spend too much time on this and that's okay. All right. Just trust me, it works. I'm not going to do the training now. Okay. It basically freezes all those things and the rest of the ones should be true. The optimizer setting, criterion setting is all lost, everything, it's all done. Then the training is the usual training. I won't go through the code. The gentleman asked me about this CUDA. This is what you do. All the tensors you should set to the right device. If it is CPU, it will be set to CPU. If it is GPU, it will set to GPU. That's important. That's pretty much it. Here also you should do the same thing. Those are the only two nuances I guess thought about. Everything else is pretty straightforward. The good thing about PyTorch, if you are not using transfer learning, you have a chance to define your own backward propagation. All those things you can do it very easily yourself. It's very easy to do. Okay. So far the code is pretty straightforward. It ran. It trained for 20 epochs. This is how it looks like. The training loss came down. The validation loss also is going down. I can probably go for some more epochs, but we stopped here. Then let me go here. And this is where the accuracy, precision, recall and F1 scores were used using the test data. And if you see the accuracy was 93%, which is pretty good. right? I didn't use all the data, I used transfer learning, only the last 2 layers, and I got a pretty decent accuracy of 93% overall. Go ahead.
My question is on the sequential model. So how did you decide to go with the sequential model and not any other?
You can try different things.
So for this kind of data,
So ultimately, I want a probability as an output, right? Or even ReLU also will work. It's not a problem. You need a fully connected layer. You want to flatten the information coming out of sorry. The question is, how did you choose the fully connected layer, right? The last few layers. This is pretty much a standard thing people use whenever they want to come out of this is the one, right? This I know what I'm talking about.
yeah. So model.s equal to array.sequential you have taken, right? But sequential, I was asking why did you choose sequential? Why not convolutional or any other technology?
Oh, you can sequential basically means that the output of this goes to the next one. That's the only thing it means, right? That's the only thing. If you want to define it in a different way, that's okay. That's perfectly okay. The key here is the in features is important. In features is the number of inputs coming in from the previous layer, right? Whatever it is, that changes from network to network. So you basically take it from, if you see that I took it from this program took it from fc dot in features, which means came from the pre-trained model. That's important. It changes from network to network. Then you say that I want to have a 512 node fully connected layer. The activation for that is ReLU. Dropout is just a feature for doing a better job in not allowing overfit. Then you have from linear 512 to, then you go to two nodes. That's pretty much what it is. And you can change that number 512 to anything else to see how it behaves. It's fine. That's pretty much it. So, how difficult do you think it is to get this kind of things done?
Is code available somewhere so we can try?
Yeah. There are lots of code available.
Not yours.
Yeah, not in the same format. I also took this code, most of certain things from other places, but this particular code is right now with me. So, I can give it to you. I think from ACM perspective, people want you to come to the Saturday course. So, so if you come to the course, we will give you the code. I think you will have at least 4 to 5 labs where we will try all the different pre-trained models. Right? That's pretty much it. Go ahead. I didn't hear that. Okay.
What's the smallest AWS instance you need to run?
No, I didn't hear that. Sorry.
What is the smallest AWS instance?
Oh, this one? Oh, this one I'm using P2 X large. That's around, it cost me around close to $1 per hour. Okay. And if you use G2, that's really, really bad. It's a previous generation GPU. It's very, very slow. I think whatever AWS says they are giving us, I don't think they are giving us. To be honest, if I have a PC in my home, it works really, really fast. So if you have a PC, a decent PC with one 1080 Pi, the game thing, whatever GPU, that works very, very fast. Okay. Any other questions? Go ahead.
So you can use TensorBoard with PyTorch.
No, I didn't hear that.
TensorBoard with PyTorch.
TensorBoard? No, I have not. Why, for seeing your this one? Those are all fancy things. Yeah, so the question is, can you use TensorBoard with PyTorch? Yeah, as long as you can see the graph where the activations are happening, it's good. I have not used it. Sorry.
Yes. If you wanted to use this particular process for diagnosis of the infection,
Yeah.
rather than just it's infected or uninfected, then you would just need to increase the number of classes, because there are like 4 different vulnerable plasmodia, 4 different genus species, and so you would just say 5.
5 classes? Yeah. If you want to classify them into different types of diseases or different conditions, right? Conditions, then you have to train them accordingly. You can do that. And in some situation, you don't want to say whether it's good or not, you want it to locate the problem. Then you start using image segmentation. So it will actually put a circle around, it will actually show where the problems are. But you had to then you had to go through the painful process of creating the label data. It's very important. You have to create that. Once you do that, it will do the job for you. For image segmentation, there are pre-trained models available. Any other questions?
Have you had a chance to use the C++ wrapper for PyTorch? Or you glad using it?
No. Why do you want to use it?
No, I was just wondering because I saw that it was there.
Yeah. The question is, can we use the C++ wrapper for PyTorch? I think it is underneath that.
Yeah, there is one, but I'm not sure, like, I'm just curious.
So I'll tell you the solution what we used for the previous company. It was manufacturing defect detection. Going from the solution perspective, right? Our job was to detect 40 images per second. If you divide 40 images per second, what happens? Like 1000 divided by 40, it comes to 25 millisecond. That's what the number is. For the whole end-to-end 25 millisecond. Out of which for scoring, you probably will get 10 or 15, 12. Because you need some pre-processing, you need some processing, all those things take enough time, right? There's a lot of delays, inefficiency built in there. So you're given only 10 milliseconds. So that's your goal, right? Then you have to have a model which can do the scoring for that. So training I can do wherever I want. I can use TensorFlow, I can use PyTorch, I can use Caffe, it doesn't really matter. Finally, I had to come up with a model which can run fast. So we chose OpenVINO because we are going to use a Intel box. So OpenVINO can actually take any model, convert that, it will convert that to using MKL libraries and everything, so it can run really fast. So that's how we came with the pipeline. So we know we had to get a model out which can be used with OpenVINO. I tried Keras, and that's a 2 months effort I was telling you, right? We did all those kind of things, and finally OpenVINO, we had connection to all the lab and other people. They came back and said that we could not convert this, they converted properly, but it was not producing good fast results. What the hell is going on, right? It's supposed to produce 25x or 30x, it's not happening. They came back and said that you have to start from TensorFlow. If you start from Keras, there are some problems. So these kind of, so we are actually working for a customer, right? If you encounter these kind of problems, you're running against time, right? So we were really worried what to do. So I started using straight TensorFlow. Can we do this using straight TensorFlow? Again, the pre-trained models, I think somehow Google's approach with pre-trained model was they want us to use their own APIs. We don't want that. We want the model so that we are completely detached from their framework, right? There was some confusion going on there. I haven't gone back and checked what they have done. So I just started playing around with PyTorch. They gave us a beautiful model. We get a very good accuracy with less number of images. And from PyTorch, you can convert, I think the code for converting that into Onyx is this one. I haven't shown the whole thing now. So this is the Open Neural Network Exchange Onyx. And I take the model, I convert that into a CPU based model. This is one command, export the model. Now it has got a .onyx file. And if you go to OpenVINO, they have programs which will take an Onyx file, which will show you on Saturday, and convert that into OpenVINO model. Boom. Once it goes to OpenVINO, OpenVINO doesn't care about how you create the model and other things. Everything is divorced from each other. So you have to go for the best possible framework for creating the best possible optimized model, the best possible framework for running your inference. That's the key.
So have you found pre-trained? So I see everywhere, including with TensorFlow, that it's been really well applied to two-dimensional image classification problems. I'm confronted with applying this to three-dimensional vision problem, meaning essentially volumes being classified as good or bad. I'm wondering if you found any pre-trained models in PyTorch or 3D.
No, the only models I've seen here is what I listed below. It has the video.
Yeah, video classification. Do you have pre-trained models?
Yeah. Whatever I listed there is a video pre-trained model is there. And you can go to that website and check it out. Where is that? Here it is. PyTorch.org docs stable / torchvision/models.html. You can go here, open link, see the classification, they got classification. Let's go all the way down. 2+1D, mixed convolution, video classification. So we'll do a lab on this on Saturday. So they have, I was surprised to see this too, right? They did, and, huh?
Much better than TensorFlow, like you're saying. TensorFlow, DeepMind is hiding all the stuff underneath just for
Yeah. So as I was explaining him, everything is divorced from each other. Once we create the model, I don't care about PyTorch at all, right? Once I have the model, I want to go and deploy it wherever I want, and that's very important. We don't want to be tied to any particular framework. Then it becomes a problem.
Are we also doing the nonlinear, NLP on Saturday?
Oh, there is, yeah, we will do the Pi transforms. They're calling themselves as the next ImageNet for MLP. So we'll explore that area, NLP area, because that's very fascinating area. And if you are trying to learn into a good data science career, NLP is pretty hot, very hot at this point. Because it's the NLP applications will go to regular businesses for chatbot, customer service, reading PDF documents, reading all of email communication. That's what people do all the time in a regular business. Everything will get automated in the next 5 to 10 years, trust me. And there will be a lot of applications rolled out, and the business, the way people do business will change. And NLP will play a huge role. Any other question? Okay. All right, it's 8:30. I had a few other demos. I think I went through most of it. Okay, so I talked about OpenV. This is the result. After all this training and everything, this is what it's doing. This is all the holdout data set. This was not used in training. It got this right. This has got the whatever it is. This has got the defect. This has got the malaria again. Malaria, yes. And here it is paradise. And here prediction is unaffected. This is a good one. And here this is a false positive. It thinks it is having a problem. You can see that why. Right? There's a small spot here. It's actually unaffected. So this probably will be a false positive. Again, it's unaffected. This is good. Here also it is saying it is positive, because probably it's looking at these defects, but actually it is not. It's unaffected. So not bad. Okay. All right. What else do I want to go through? That's pretty much it. I'll open up for questions in terms of any specific problems you want to talk about. I have other things, but it is we'll reserve that to Saturday. Yeah.
I actually have a question. I don't know if that's relevant.
Sure.
So, say for example, you have a one-dimensional time series data. You have a one-dimensional time series data.
Okay.
You're talking about a situation where you don't really have a training yet. Let's say like a max 2000. And you're probably trying to do a binary classification.
Okay.
How do you approach this problem if you want to use a pre-trained model?
I don't think there is any pre-trained model, first of all. I heard people done it. I have not done it myself. What they did was they took the graph, whatever the graph, actual graph, that's a two-dimensional image. They used it as for training. Yeah, I heard people did it. I don't know how successful they were. They were actually taking the images as a two-dimensional image, not a time series data, even though it has that this one. Then they were feeding it for training purposes. You can try it out, see what happens. Okay. Any other questions? All right. Great. If there is nothing else, I'll stop my presentation. Thank you for listening.
I just wanted to mention the